Good morning, everyone. My name is Ross Hansen. I work for Axcend Corporation in Provo, Utah, and I'll be speaking today about the topic of Cannalytical chemistry and ways to improve your laboratory operations to make you greener, cleaner, and more profitable. Before we start, one very big note. I'm going to introduce you to somebody who's certainly going to interrupt my presentation. That's Woody the Great Dane, and at some point, he's going to stick his head in here and get in the way. So bear with me. I'll do the best that I can. So I'm a big fan of a guy named Colin Powell. If you know who he was a general and Secretary of State, but he actually made his reputation as a teacher and a trainer in the U.S. Army. He was well known for that. And one of his key mantras was, tell them what you're going to tell them, then tell them, and then tell them what you told them. So what I'm going to tell you about today is today's key learnings. We can use modern analytical tools to do a better job of keeping our labs greener and safer for our employees and for our customers and for, of course, our environment. And customers do care about green chemistry. It's easy to go, oh, wait a minute, my cannabis customers are a bit stoners. They really don't care. I assure you they do. And the way you know that they do is that if you look at every vape cartridge manufactured, some are CO2 extracts and some aren't. And the CO2 ones cost more because they're cleaner and greener. And people pay for that. They pay for the better, cleaner product. So let's not forget that that's important. Let's use first principles of science and specifically of chromatography to make better decisions, better accuracy, and to get better LODs and LOQs, limits of detection and limits of quantitation. And finally, by having better data at the point of need rather than over in the laboratory, perhaps we can get better business decisions more rapidly. And I'll talk about specifically how that can happen in a few moments. But to start, I want to start with some basic principles. I want to start with something chromatographers call the Van Diemmeter Equation. And Dr. Van Diemmeter was a guy who applied rate theory to the chromatography elution process of peaks coming out of a capillary or regular bore HPLC column and GC columns. It applies to all capillary chromatography. What we can see here in this slide is that if we plot plate height versus flow rate, it says in this chart, and we'll talk more about that in a minute, because it's not really flow rate, but it shows that the maximum efficiency of our columns, of our science, happens when we work at the point where the curve, the parabolic blue curve that you see, is at its lowest point. The lower that number is, the more efficient your column is. And I'll explain why in a minute. But it's important that we get the most efficiency out of our products, whether they're columns, LCs, whatever we're using. And the reason for that is the more efficiently we operate, the less money we spend to get the results that we need to make the business decisions that we need. A little bit more detail on the Van Diemmeter curve, and you'll notice that now the x-axis is not labeled velocity, it's labeled mobile phase velocity. It turns out that the speed of the mobile phase, which of course is directly related to the flow, but we calculate velocity because that's the calculation, the number that gives us the correct answer from the Van Diemmeter equation and gives us the best answer for where we should be working scientifically. So you can see, if you look inside the circle in the dotted line, as I described before, that low point for plate height is the most efficient place to work. Why is that important? Well, we'll talk about that in a minute, but think efficiency, not just of the column, but of your applications and of your operations. And we're going to talk a lot about how to be better in every facet of your operation. But let's talk about what those operations are first. I think before we can do that, we have to consider, what do cannabinoid scientists look at? Well, we know that they look at plant materials in the field, they look at incoming quality control, and boy, do I have something to say about how you test product that comes into you. Because it's really important when you buy in product and then formulate it or extract it, you have to know what you got. In process monitoring, as we're extracting, as we're isolating, as we're purifying, are we being as clean and efficient as we can be at getting the best product for our customer? I happen to do a lot of business with Curaleaf, and I've tested their products myself, and I can tell you that we get some great results from Curaleaf. I can't speak to others, I haven't tested them, but I have done the Curaleaf products. Oh, and I forgot to talk about formulated product testing. When we talk about formulated product testing, one of the things that we always want to be sure is that the product we're formulating actually is starting at the right point. We know that cannabis changes in its environment over time, and so we want to pay attention to how the changes occur, where they occur, and how do we make sure that we still get our formulation right as the plant changes. One of the things we did to look at this was we went to a greenhouse in Utah. It's near our office. As I said, we're headquartered in Provo, although I happen to personally live in Sarasota, Florida, and I have a funny story about that in a minute. But anyway, living near Utah, or having our office near there, we were able to go over to the greenhouse and do something you've probably never seen before. And since you can see my camera, I'm going to show you something to look at, and that's an HPLC that you can actually carry around with you. It's an LC with a handle. Pretty cool stuff. Why is that important? Because it turns out that sometimes you don't want to bring the sample into the laboratory. You want to bring the laboratory out to the sample. Here's a fast cannabinoid profile. It took about 6 minutes, and you can see that what we got in that 6 minutes is a profile of a half a dozen compounds. We could do more, we could do less. This is very adaptable to your specific need, and you can adapt these methods by customer. So you can actually assign a method to a customer if you're a contract laboratory and they're sending you a sample and they want to know 5 cannabinoids. Wouldn't it be nice to have a method that belongs to customer XYZ and you get him his cannabinoids exactly the way he wants them? I would point out to you something very important about this chromatogram. If you look at the peaks between 3 and 4 minutes, you'll notice that there's 3 peaks inside of a half a minute, and they're all pretty close to baseline resolve. They all have resolution factors greater than 1. When you look at that, why is it important? It's because we're getting 3 peaks out in less than 30 seconds. Or in other words, each peak is less than 10 seconds wide. Why can we do that? We can do that because of what the slides along the side, or the data along the side of my slide tells you, which is that these are columns that are 0.15 millimeters in diameter, 0.15 millimeters. Most of you are almost certainly using somewhere between 2 and 4 millimeter columns. A few brave souls may be using 1 millimeter columns, but you're not using 0.1 millimeter columns. Why is that important? It lets us work at a flow rate of 1 to 2 microliters, not milliliters per minute, and maintain, if we go back to that Van Diemmeter curve, we can stay in the most critical part of the curve and get our best results while still maintaining very low flows, and as you can see, getting beautiful separations. The point that I'm making here is you're using less solvent, so it's costing you less money, and it's exposing your scientists to less overall toxic waste. Equally importantly, when you buy a milliliter of solvent, whatever the solvent is for HPLC, whatever you spend to buy it, you have to spend about the same amount to get rid of it again. It's hazardous waste and it has to be disposed of. That gives you the opportunity here to cut not just your solvent costs, but your waste disposal costs significantly. And we'll talk about the business of the laboratory in a minute. But right now, let's focus on the science. When we come down to our next slide, you can see equally great peaks. You can see that they are mostly baseline resolved, and equally importantly, you can see that these peaks are sharp, easily quantified, and they give you the best possible answer you can get. Now, I'm going to go on to one more slide about chromatograms. And here's why it's so important to make a measurement as close as possible to when you need the right answer. You look at this hemp extract. You'll notice that it's all CBDA, CBGA, and THCA. There's almost none of CBG, CBD, or THC. Why is that? Well, they were probably stored in a way that allowed the acid to form rather than keep it in the other form, the THC, the CBD, the CBG. We can monitor that so when you go to formulate a product, you know, hey, wait a minute, this is the carboxylic acids. We don't want that in our product. We really want the CBG and the CBD. We can convert that. We know how to convert that with heat, with whatever. So we can make a better decision before we begin processing, before we begin delivering the goods, if you will. One of the questions though, and by the way, I'll note, if you look at the first peak, the CBDA peak, look at how sharp it is. I assure you, if you go in your laboratory and look at your chromatography, you can't do that. You can't do that. Why is that important? Every day we're learning that there are more compounds in the overall profile of cannabis and hemp that are either medically or commercially or recreationally important. They enhance the customer experience. The more peaks you can jam in there, the more you can weigh. So if you have big fat peaks, you can't get as many analytes in a given analysis as you can if you have narrower, sharper peaks. We can do more, faster, cheaper. So I encourage you, again, this is about capillary chromatography, not specifically our instrument or anybody else's. This is about using the modern scientific tools to enhance your results. But how good is the data? I've never done capillary chromatography, you say. I understand it's a real pain in the neck, and we'll talk about that in a minute. But how good is the data? Well, I encourage you to look at this chart, and you can see 3 nines something all the way through where we've detected a peak. And you can see that we've got linear ranges of 3 orders of magnitude or better. So you can work across a broad range. You can get incredibly precise and accurate results, all of which will translate to a better experience for your scientists, a better experience for your business people, and a better experience for your customers. But you know, at the end of the day, we all have to make a living. There's very few people that work altruistically. We have to make a profit in our companies. The reason companies exist primarily, except for not-profits, is to make a profit. So let's talk about managing the assets wisely at work. Let's make sure that the assets that we have, we're conserving and applying as well as possible. Wasted money reduces profits. Frankly, it reduces your boss's opportunity to give you a raise. It reduces opportunities for new markets and business, because when you're spending money on solvent and waste disposal, you're not spending it on marketing. You're not spending it on investing in new markets. You're not spending it on investing in the education of your people or enhancing your facilities. You're just creating waste and burning waste. It's better not to do that. And I want to encourage you to not think about money as money. Money isn't really what we often talk about when we talk about creating value. We can create time as money. Lost work days are money. Energy costs are money. Wastage is money. Creating waste is money. So as we consider what are the ways that we might look at this paradigm of I want really great results, but I don't want to spend more money to get it. What if you could spend less money and get better results? What if you could save the entire cost of the instrument just based on switching to capillary? Here's some operational savings, and we took these. I want you to ignore the actual dollar values we used and look at the ratio when you're running an HPLC with a 4.6 millimeter column versus a 150 micron column. There's a huge difference in what it costs you to run the instrument. In our case, we just took the list price for Fisher Scientific. We know nobody pays list, we get that. What we did is we took that number and about $100 a liter for waste disposal. We didn't know if that was the right number. We heard that anecdotally from a couple of labs, but again, it doesn't matter. It's the ratios. Whether you're spending $10,000 or $30,000 on this, you're spending a lot of money. We can cut that money by a factor, look at the factor, $250 instead of $32,000 in this calculation. You are throwing money out the door. You're just throwing it away. You shouldn't be doing that. Common sense says, let's do something smarter. What does smarter look like? Oh, wait a minute. I didn't even talk about the cost of actually running the instrument. One of the changes that you can make in your instruments is to substitute light-emitting diodes in many cases. We have them in our homes now. We call them LEDs, and they're in our kitchens, our ceilings, everywhere. Why not use those specific wavelength LEDs to lower the energy cost of running our instrument? Not only don't we have to make the pumps pump much higher volumes of solvent at high pressure, which costs money, but we can lower the amount of money you spend on lamps immediately. A diode, as you know, typically lasts about 20,000 hours. A comparable deuterium lamp lasts about 2,000 hours. So you can improve your performance by a lot. We calculated using the ACS AMGS green chemistry score, and we calculated the energy costs. I live in Florida, so I took the cost in Florida of 0.13 dollars per kilowatt hour, and you can see that you save, again, an enormous amount of money. 80% of your energy costs go down when you're using HPLC that's capillary instead of using HPLC that's normal bore. We can save you money. And I want to give credit. These calculations did not come from me. I'm working with a scientist at Merck named Mike Hicks. Mike Hicks did these calculations. I'm just reporting his data. So I want to give credit to those guys. And I want to bring up another point. You'll notice that I mentioned pharmaceutical companies. I do a lot of work with pharma. I have throughout my 30 or 40-year career. I want to tell you that cannabis is headed for the paradigm that is pharma. Today, it's not quite in the pharma mold, but it will be. We're making substances that people eat, that they drink, that they ingest somehow, either for a health benefit or a recreational benefit. And we need to know that we're not hurting anybody. Ultimately, we can expect the entire cannabis party to move under the tent of the FDA. It's probably 10 years from now when the FDA finally wakes up and goes, yeah, okay, cannabis is really a medicine. But at some point that's going to happen, and we should prepare for that as soon as possible. A lot of what I'm talking to you about today are ideas that the pharma community has long since embraced. Bringing the lab to the sample, bringing the instrument right next to where you need it, those kinds of things. The instrument I showed you, which is our product at Axcend, was designed with the pharmaceutical market in place, not with the cannabis market. But since cannabis is a subset of pharma, it works very nicely. One last thing I want to talk about when we talk about employee health and safety. I wonder how many of you ever thought of what acetonitrile really is. Did you ever look at the formula? Well, I got a hint for you. It's methyl cyanide. When you use a 4-liter jug, a gallon of acetonitrile, you're exposing your employees to methyl cyanide. That's cuckoo puffs. We want to limit that as much as we can. Why wouldn't you want small vials instead of large jugs of carcinogens? And I will show you, if you look at the picture on the right, those 3 vials that are in the front of that HPLC, and that is an HPLC in spite of its size. It's a 10,000 PSI HPLC that has a handle. Those 3 vials hold solvent A, solvent B, and waste, enough to run for an entire week. They're 9 milliliter vials. An entire week on 9 milliliters. Doesn't that make sense to your lab? Doesn't that make sense to your employees? Doesn't that make sense to your company? I think it does. And by the way, when we go to smaller instruments, we can also start to put them in safer places, like hoods and glove boxes, when they're using solvents that aren't safe for the employees. How rugged is it? We know 25 years ago when Capillary came out, I was in sales at Agilent at the time, and I'll tell you what, nobody wanted to do Capillary. The columns weren't that great. To be honest, the ruggedness of the instruments wasn't that great. It's 20 years later. It's like if you bought the first electric car 10 years ago versus what they are today or what they'll be in another 10 years. It's clear that this is the trend of the industry. We're not going to keep allowing HPLCs to generate a liter of waste every 24 hours and then have to pollute the environment burning it. That's going to change. We should begin to change before we're forced to change. So where can you use capillary instrumentation? Where is it already being used? All of these places you see. If you email me, I will send you papers from every one of these industries where work is being done on capillary columns. They work great. You have to filter your samples. That's the one thing, filter your samples. But other than that, capillary columns work pretty much like everything else. And I want to give a shout out to a company some of you may be familiar with. It's ResTech in Bellefonte, Pennsylvania. If you're wondering, how do I convert my regular methods to capillary methods, go to restech.com, and on their website, they have the easy method LC calculator. You put in your normal conditions, you tell it what column and solvent system you're going to switch to, and it does the calculation, and it gets to you within about 80% of your method conversion. I encourage you to use that. Every time somebody comes to me and says, I've got this, I want to convert it, I'm way past doing that math in my head. Why not use the tools we've been given? And I encourage you to use the ResTech calculator. It's funny, ResTech doesn't sell capillary columns, but they have the LC calculator. I think that's great. And last but not least, as I promised you, I was going to tell you what I was going to tell you, and then I was going to tell you, well, now I'm going to tell you what I just told you. Analytical tools are available to make your labs better, safer, more efficient, and more cost-effective. And our customers really do care about it. I can assure you that when a company like Merck Pharmaceutical is calculating green scores for their instruments, the world is taking us seriously, and we need to take that seriously. First principles of chromatography, which have been around for years and years and years, we didn't make up new science. We just took the science and applied it to a better way to do it. And finally, by having an instrument that you can take anywhere you want it to go, you can bring the instrument to your point of need. So a hemp field, a cannabis grow house, whatever it is, a formulation station where you're blending product that you bought in and you're formulating, that can all be combined in a capillary format. I want to thank you all so much, and I wish you all good analysis. Thank you.